Hello, good morning, everyone. So my lecture today talk about radicals and rational exponent. So here is radicals, P.4 radicals and rational exponent. Okay. So any idea about radicals? What is the meaning of radicals? Did you hear about this word in your high school or before? What is the meaning of radicals? Any idea about radicals?
Is it like square root?
Yeah, square root or nth root or any root. Nth root, square root, third root, fourth root, all of this called radicals. So here, the section start talk about if I have, for example, the square root of a equal b, so I have to know this is actually equal, this is mean, this mean, if I multiply the b by itself, like I mean b squared, should give me a inside the radical. So it should give me a. This is equal a. And I have to know here b must be positive or 0. And in the same time, I have to know a is greater than or equal 0 too. So this is for the square root. For example, the square root of 9. What's the answer? What is the square root of 9?
3.
Is it 3? This is
3.
correct. Why? Because if I multiply the 3 by itself, 3 square, it will give me 9. So this is correct because the 9 is inside the radical. And I have to know the 3 and the 9, both of them positive. So the 3 and 9, both of them positive, greater than 0. This is for for the square root, but for the nth root, so the definition for the nth root, n is positive integer and so I can define the nth root of a is something like this. So the nth root of a is giving me n is positive integer. So the nth root of a is here is the nth root of a, like n of a, and this is, for example, if you give me b, the same idea like before, mean if I multiply the b n times by itself, mean like b to the power n should give me a. And I have to know when it's positive if this n here is even number. What is the even numbers? What's the meaning of even number? What is the meaning of even numbers?
Isn't it like numbers that can be divided by 2?
Divided by 2. Yeah, exactly. Like
And leave
2,
no remainder.
4.
Without any
Yes,
remainders when you divide by 2.
exactly. Without any reminders. Exactly. So 2, 4, 6, 8, 10, 12, 14, etc. Yeah, this is correct, Eric. So if n is even number, then I have both of a and b are positive or 0. So if n, this n here, if it's this even number like 2 or 4 or 6 or whatever, any even number, so most of A, this A and this B must be both of them must be positive. If they are odd, doesn't matter, positive or negative, doesn't care. So example for this, example. So for example, what is the square root? Here I give example. Example. What is the square root of 81? What is the answer here?
9.
This is 9, exactly. Why? Because if I multiply the 9 by itself, or if I multiply the 9 to the power 2, they give me 81. So this is correct. Second one, I'm going to do it in the back. Go to the next slide. So the second one, the question is, what is the third cube root of -8? What is the cube root of -8?
I want to say 2 or -2.
-2 or 2. If I
Negative.
multiply 2 3 times, they give me 8, not
It should
-8.
be negative.
What's a -2?
Negative 2.
So it should be -2. So the answer is -2. Why? Because -2 to the power 3, they give me -8. Because third one, what is the fourth root of -8? What is the fourth root of -8?
0?
Is 0.
Never mind.
0, no, 0 times 0, 0 to the power 4. They're not give me
Wouldn't
minus
it be undefined because -8 doesn't go like into a cube root properly? I meant to a fourth root because the only time it would go properly is in a cube root.
This is correct. What's about this? If n is even here, if n is even number, then both of A and B are positive or 0, right? So what is
So it has to be
the
four then, right?
root here?
Fourth.
Is even, right?
Yeah.
So 4 is even number, right? So what's inside here is a negative number. This is correct.
No.
If n is even number, this one here, this,
So is it
if n
undefined?
here is even, yes, exactly, undefined, then both of A and B, this A and B must be positive. So here I have even number 4, but inside is negative, so undefined. So I cannot find the answer for this. Why? Because the 4 is even number and inside the radical is negative. So the answer is undefined.
So if our root is even, but our number in the root is negative, it will always be undefined.
Always undefined. So if it's this even and inside here negative, always undefined. No answer.
All right, thank you.
No problem. So you have to be careful for the root here, the nth root. If it's even, so inside must be positive. Look here in the second example. Second example, the root here is odd, number 3. 3 is odd number. So inside is negative. It's fine. They gave me answer. But for the third example, the root here is 4. So it's even number. And inside is negative. So undefined. So I cannot do, I cannot find an answer for even root. Okay, is it clear? Okay, So now we have some properties for the radicals here. Properties. We have some properties for radicals. So first property. Okay. First one says number one, the nth root of A times B, I can split it to two radicals. The first one is the nth root of A times the nth root of B. So example for this, example, the third root of minus 27 times a 64. So this is actually equal. We can split the radicals, two radicals. The first radical has minus 27. The second one has a 64. What is the cube root of minus 27?
Will it be -3 or positive?
Yes, this is correct. -3. Why? Because -3 to the power 3, they give me minus 27. So here the answer is -3 because -3 again times -3 times -3, they give me inside minus 27. So this one, the answer is -3. What's the cube root of 64?
4.
Say undefined.
It's 4 exactly, because
Why
4
is it-
times 4 times 4, they give me 64. Yeah, what's your question?
3 is not even.
The 3 is not even. So inside could be positive or could be negative. It's fine. Any number inside. No problem. But if it's even, should be positive. Must be positive. So here, minus 3 times 4, they give me minus 12. The second property, number 2, said that the nth root of A over B, you can split it into two radicals, the nth root of A over the nth root of B. Same idea like before. So for example, if I have example here, the third root of 27 over 64, same idea, we can split the radicals two pieces into two pieces. The first one is the cube root of 27 and cube root of 64. So here they give me 3 again, and this they give me 4. So 3 over 4. The third property says if I have the nth radical of the nth radical of A, so this is equal, just I can get one radical is A inside, and here we can multiply the both of the roots, the m times n, so m times n. Okay, so example for this, easy example, the cube root of the second root of 9, this is equal what? What is that equal?
3 times 2.
3 times 2. And 3 times 2 equal 6. So the sixth root of 9. And we have the last property. So I'm moving to the next slide. So the last property here, number 4, said if the nth root of a to the power n. So I can cancel the n with the root. But if n, I can't cancel any, like I can't do it right away. I have to know what's the value for n. So if n is odd, the answer A. If n is odd number and the value they give me the absolute value for A if n is even. So what's the odd? The odd numbers are 1, 3, 5, 7, 9, etc. And the even, like I said before, is 2, 4, 6, 8, 10, 12, whatever. What is the absolute value? Any idea about absolute value?
I can't really explain it, but like it has to do with how many numbers before zero, something like that.
Yes, exactly. How many numbers before zero and what else?
It's
Who will give me the distance? Yes. What else?
It can be negative, right?
Yeah, Shop. Do you have any idea,
Right.
Shop?
yeah. Absolute value means any number that I mean it could be a negative, but we make it to positive.
Exactly. So here turns, like Eric said, turns a negative into a positive. This is correct. So they changing every negative to the positive, and we keep the positive the same. Like for example, the absolute value for 3 is 3, but the absolute value for minus 3, they change it to the positive, so they give me 3. Same things, the absolute value for minus 5, turning the negative to the positive, they give me 5. So they're keeping the positive the same, but the negative, we have to change the sign from negative to the positive. This is what the mean of the absolute value for A. So the same things here for radicals. So we can cancel the radicals with the root, with the power. But if A is odd number, if A, this A, I mean, if n is odd number, so the answer is A. But if n is even, this one here, if n is even, so the value, the answer is the absolute value for A. Now I give you example for this. The third root of x to the power 4. So to solve something like this, we have to split the x to the power 4 into 2 pieces. So I get now the third root of x to the power 3 times x to the power 1. So actually x to the power 3 times x to the power 1 is equal x to the power 4. Why? Because we learned this in the last class. We have the same base, different power. So we just adding the power to itself. So this is equal x to the power 3 plus 1, they give me 4. Now we're using the properties here. We split by using the first property. We split the radicals into 2 pieces. First piece is the third root of x to the power 3. And the second radical is the third root to the x to the power 1 or x. Now here, this one, by using property number 4, and here is odd. So this means the answer, they will be give me the A, this A. I mean, you give me x. A here is x times, here just we send it down, move it down because we don't have to do anything. So the answer is x times the third root of x. Is it clear how we do example like this?
Hold on. So I have a question, right?
Yes.
So you see two ends, they have to be the same in order to do this, right?
Yes, must be the same, 3 and 3.
And
The n must be equal.
one more question.
Yes.
So you know how you expanded here, x to the 3 times x to the first power? Could we have expanded x to the
Yes.
2 times x to the 2?
Yeah, we can do that, but we will not like get any answer. Like I need to use the property. I need to use this property, number 4, property number 4. This is the important property because I want to cancel the radicals. My goal here to cancel the radicals, cancel the root. So by using, if I put it 2x to the power 2 times x to the power 2, I will stuck. I'm not going to do anything. Just we separate it and I will not do anything. I stop. But here, because I put it 3 and 1, so the 3 I can cancel it with the radicals by using property number 4. The 3 with the 3, because here n is odd, the 3 number 3 here is odd. So the answer is A. I mean, A here is the same as x here. So the answer here x. And we move this down. Makes sense what I did here? So I tried to put one of the variable has power with the same radical, and the other one has the rest of the, like I mean the rest of the bars. I mean like if this is 4, here I have 3, so the rest is 1 because I need the total give me 4.
So it cancels out. This cancels out
Yes, I
because
want
it
to
has
cancel
3
out.
and 3.
Exactly,
Okay.
correct. Yes. So another example. So example here, another one. So if I have the 4th root of x to the power, for example, 5, same idea exactly. So one of can split it to the 2 pieces, the 4th root of x to the power 4 times x to the power 1, because 4 plus 1, they give me 5. Now we split the radicals into two pieces, the 4th root of x to the power 4 times the 4th root of x. Now, going back to the property number 4 to cancel the radical, so n is even here, so I have to use the absolute value. So the answer now here, the absolute value for x of x times the radical, the 4th root of x. Clear?
We can't really see the bottom.
Okay, so this is equal here, the absolute value for x times the 4th root of x. You can see right now?
Yes, thank you.
Okay. Why it's absolute value? So the Eric, he asked why it's absolute value, because we have 4. The 4 with the 4 here, they cancel each other, but by using the property number 4, n is even. The 4 number 4 is even, so I have to take the absolute value inside the radical. The absolute value of x. That's why. Okay, third property. Third one, if I have the nth root of the nth root of a, so I can multiply m times n, and I get one root only, one radical. For example, if I have the third root of the second root of 9, so I can multiply, I get one root only, and I multiply 3 times 2. They give me 6 of the power of the sixth root of n. Okay, Ahmed?
Yeah, thank you.
Okay. Other questions?
Yeah, so do we leave it like that, or should we go ahead and find the absolute value of x?
No, like this. You leave it like this.
Okay, thank you.
Okay. Okay, so now let's moving to the next part of this section is the rational exponent. So this is the radical exponent, now the rational exponent. So we're starting by radicals. Now we're going to talk about rational. So here radicals. radicals. This is for radicals. Now we're going to talk about the second part. Is here is the rational exponent. Okay, and this one here, radicals. So now rational exponent. Okay, rational exponents. In the beginning, we have to know if I have any a to the power m over n. This is mean that the nth root of a to the power m. So this is m here. This is m. This is m here. Here m. Here's m. And this n down, down. Here is n. This is n. And here is the a to the power m. Or I can say a to the power m over n equal a, everything like m over n, again m over n. So this is the n here and the m over here. So this is m here. So example for this, example, where is 4 to the power 1/2? What's the answer for this one? So applying this property,
So it's gonna be radical 2.
what is that? The radical of what?
2 on the corner, top 2 radical, and
Second
then
root?
4 to the first power.
Yes, exactly. So now, what's the square root of 4?
2.
Is 2. So the answer is 2. Correct. The second example, this is the first one. Now, the second one is 125 to the power minus 1/3. What's the answer? What I have to do now here?
It'll be radical 3 to the square root of negative 125.
Radical
No,
3
positive 120.
to the negative 125.
Yeah, because our exponent is negative 1/3, right?
Yes. But the negative not should be goes to the number inside. This is for only for radical. I mean, so what's the mean of minus when I see minus for the power? Like
So
I
it's gonna
said
be
last time.
square 3 square root 1 over 125.
3 square root like this. Square root
Yeah.
like
No,
this.
No.
What?
3
What?
goes on the corner.
Oh, 3 goes to the corner like this. Like
And then
125, right? Which root is that here? Which root here? 3.
you put 3, and then you, since it's a negative 1 so exponent, so you just flip it to 1 over 125. Is that how you do it?
Exactly. So correct. So yes. So when I see here negative 1, this is mean. So I have to write it like this. Third root, cube root of 125 to the power minus 1. And the power minus 1, this is mean I have to flip it down. So this is actually equal 3, 1 over 125, like this.
Is it 1/5
And
by any chance?
exactly 1/5, 1 over 5. So I can distribute the radical like I learned before from the property number 2, distributing the root, the radical. So I get the third root of 1 over the third root of 125. Third root of 1 is equal 1, always 1. And the third root of 125 is 5. So the answer is 1 over 5. Okay. Any question for this? Okay. Here. So this is clear here.
Yes.
Okay. Any question for this property here? Now we have to go to simplifying, like we learned in the integer root. I mean, in the integer exponent. Now we're going to learn it in rational exponent, how we can simplifying. So I'm going to go to the next slide. So here simplifying. So the question is, example, simplify 2a to the power 3 over 4, everything to the power 2 times 7a to the power 1/2. Who will help me for doing this one?
I can try.
Yes, go ahead.
So first you distribute the 2 to everything. It's like 2 square root of 2 and a
Exactly.
times.
Correct. So I have 2 to the power 2 and a over times here it goes down 7 a to the power 1/2. Now we can simplify this side. So 2 to the power 2, they give me 4, right? And
Yes.
here a 3 over 4 times, we multiply the power when we see something like this, power over power. So 3 over 4 times 2, they give me what? 6 over 4, right? 6 over 4 times 7 times a to the power 1/2. I can simplify here. 6 over 4 is 3 over 2. And I have to multiply, like I said last time, multiplying the numbers together. Combine the
Which is
numbers together.
28, and then
Yes.
the bases are the same for the a. So you just
This is
add
correct.
the exponents. You have to make sure the denominators are the same. So you multiply 2 to 1 both sides. That's 2 over 2. So that's 8 over 4, which is 4 over 2, which is 2, I think.
But we can simplify this here. This
2 on both sides. That's 2.
we can simplify 6
over
over 4 such that a to the power 3 over 2. And we have here a or 1 over 2. So the base are equal, a and a. but the exponent are different. 3/2 and 1/2. So we just adding the exponent. Now, 4 times 7, they give me 28 times a to the power 3/2 plus 1/2.
which is
What's they give me? Shop,
just 2. So 28a squared.
they give me 4/2, and 4/2 is 2. Correct. So the answer is 28a squared. For this, okay. So again, we combine the numbers together, and we combine the variable have the same letter together. So 4 times 7, 28, 8 to the power 3/2 times 8 to the power 1/2. And we have the same base, a and a. So we just adding the exponent, 3/2 plus 1/2. 3/2 plus 1/2, they give me 4/2. Here, 3/2 plus 1/2, because we have the same denominator. So we just adding the numerator 3 plus 1/2. And this is give me 4/2. And 4/2 we can cancel and simplify it to 2/1. And this is actually equal to. No, we can, yes, do we keep simplifying example
Multiply
28
this
times 2?
2 again. It stays like this.
Yeah, you can keep it like this, 28 times, or without the times a squared, a to the power 2. Do we keep simplifying? No, this is the simplest things, Eric. Eric, this is the simplest things. We cannot simplify it more than this. Any question for
If
this?
there was a parentheses like 28a squared, then you can distribute the 2, but this is the simplest one.
Yeah, the simplest. We can't do more simplifying more than this. So we stop up to here. Another example here. The example is 2x over y, x here over 3/4, and the y is 1/3. Everything to the power 3 times y to the minus 1 over x to the power minus 1/2. Okay. Who will help me for doing this one?
I could try.
Yes, go ahead.
So first you distribute the 3 to 2 and
Yes.
x to the 3/4. Same thing to the denominator as well.
Exactly. So we distribute the 3 to the power here inside the parentheses. So they give me 2 to the power 3 times x 3/4, everything to the power 3 over y 1/3, everything to the power 3. Now for the second one, because we have y to the power minus 1, what does that mean? The minus exponent, what does that mean?
You simply just reverse. X is on the top, y is in the bottom.
Exactly. So we have to move this one down because we have minus. The minus exponent means we should to move this one to the denominator. So I get here y to the power 1. So I keep it y. And here we have x to the power minus 1/2. So the minus mean we should to move this one, this variable up to the numerator. So I get here now x to the power 1/2.
No,
Okay.
you get x to the just half. X to the x squared. You don't get 1/2.
1/2. It should be 1/2 because here the minus mean we have to should move everything here up without the minus.
I know, but think of it. When you move it up, it's not half. It's just 2.
It's just 2.
If you
no.
move it down, that's 1/2.
No. This is no. The 1/2 mean x to the power 1/2. This is mean the radical. Is not moving up or down the minus, the sign. For example, x to the minus 2. If here instead of minus 1/2, for example, if I put x to the minus 2, minus 2 means we should move this one up and will be like x to the power 2.
No, but think if it was, let's say, x to the negative 2, right? Then
Yes.
it would be 1 over 2x. So when you move half in the numerator, it should be 2, not 1/2 anymore.
No, okay, I see. Okay, let's listen to me. Here, when we move this one, I forget the bar. I keep the bar the same, but the minus, we have to change it to positive. To change it to positive, I have to move everything up. And I keep this inside the red parentheses like the same exactly. Look, y to the power minus 2 over x to the power minus 2. For example, this 1 over x to the power minus 2. This is when we move this one up, I cannot say this become x to the power 1/2 positive. This is not correct, not equal. But the equal for this one is equal x to the power, just I have to remove the minus, the sign of the exponent too.
Right.
So the same things for this one, 1 over x to the minus 1/2. The same idea. This is equal, moving this up, this is equal x to the power 1/2. Positive. Make sense? And
Yes.
the 1/2 means the radical. The second root of x over 1. This is the mean of the 1/2. Does not affect in moving this up or down. This is means radicals here. Make sense? So here for this one, for our example, the y to the power minus 1, we move this one down and become positive 1. And for x to the power minus 1/2 should be moving up. So it will be x to the power 1/2 positive. Okay. Now, let me simplifying this. So I'm going to make one fraction for everything. So 2 to the power 3 is 8 times x to the power 3 over 4. We have to multiply the 2 power. 3 times 3 is 9. So I get 9 over 4 times x to the power 1/2. Here I have y to the power 1/3 to the power 3. So we multiply the 3 to the 1/3. So I get 1. So I get here now y to the power 1 times y. Now to simplify this one, so the variable, the numbers together, so I get the 8. The variable have the same base, so x and x, they have the same base. So we just adding the exponent together, 9 over 4 plus 1/2, x to the power 9 over 4 plus 1/2, everything over y to the power, here we have 1 and here we have 1 to the power 2. Just we adding the exponent. Now 9 to the power 9 over 4 plus 1/2. What is the answer here?
It's 11 over 4. You have to multiply
11.
2 times 2 on both sides to make the denominators both 4.
Exactly. So if I multiply both sides here by 2, I'm multiplying this one by 2 and this by 2. So I will get 9 plus 2, 11. And here the denominator are equal, so 11 over 4. So now the answer is 8 times x to the 11 over 4 over y squared. Any question for this? The students, the other student, do you have any question? Makes sense? Clear? Okay. So another question in web assign. Another question in web assign. The question is, so here example, 14 to the power 4 over 5 times 14 to the power open box like this equal 14 to the power 1. The answer, the question is, what is the value I should to put it inside the box? Any idea?
Is that a 0?
If I put here 0, they give me 14 to the power 1, 0, they give me 1, right?
Yeah.
Times
Oh, that's a 0.
14
Okay.
to the power 4 over 5. And 14 to the power 4 over 5 does not give me 14 to the power 1.
I think he's asking if the square is a 0.
What's what's the value I should?
The little box.
It's 5 square root 14 over 4. The n is 5, I think.
So what I should to put in the inside the square in this box here? What's the value?
I'll say 1.
1. So okay. First of all, when you see something like this, question like this, here we have the same base. So this is mean if I have the same base and we have multiplied between both of them, this is mean it should be like this, 14 over 4. We have to do just adding the sum. We have just adding the exponent equal 14 to the power 1. Eric, he said 1 over 5. Can you explain, Eric, how you find the answer? So Eric said inside the box we should to put 1 over 5. So 1 over 5 plus 4 over 5, they give me 5 over 5. And this is actually 1. And this is correct. Yes, this is correct. So inside the box, I should to put what? 1 over 5. Because again, the both numbers are multiplying together and we have the same base, 14 and 14. So we just have to put 14 and we have to add the exponent 4 over 5 plus this box equal 14 to the power 1.
So
The
don't you
one
just
here, this actually
you just
5 over 5. This one is 5 over 5. So here I get 4 over 5 plus what? That give me 5 over 5. So
you just
4
subtract.
plus over 5. Yes, subtract, exactly. So this is equal 1. And again, 4 over 5 plus this box equal 5 over 5. So I have to subtract 4 over 5 from both sides. Subtracting 4 over 5 plus from both sides. So I'm gonna get this box equal 5 over 5 minus 4 over 5 minus 4 over 5. And this give me 1 over 5. So inside the box, I should to put 1 over 5. What does the box mean? And I don't understand how you got 14 to the power of 1. The question is, what value I should to put inside this box? The question like this, exactly, 14 to the power 4 over 5 times 14 to the power box equal 14 to the power 1. What
think it-
value I should put inside the box?
I think
Ahmed,
I
he
can
say
make it a
ask.
little easier, right?
How?
So think of you're finding x on 14 over 14
Exactly, x.
to the x power. So
Okay.
you can say 4 over 5 plus x, that gives you 1. So you can just solve for x, and then that should give you x equals 1/5.
Exactly. Nice.
It's,
So we
it's
can
like a
solve
little
it as
equation you can set up.
yes, like you can solve it as equation. Instead of this box, I just put x or y or any variable, and you solve it like equation, simple equation. Any
This is,
question?
this is only because the bases are the same. If they're different, then that's a different story.
Yes. If different, we cannot work like this. Yeah, the answer is 1/5. Ahmed, he asked, so the answer is 1/5. Yeah, yes, this is correct. 1/5. Makes sense? Any question for this section? Okay. Now let's go to the next section is B5 called algebraic expression. B5. B5. Algebraic expressions. Okay. First of all, we have to know some definition. What is the meaning of algebraic expression before we start for definition? So if I have, for example, variables like x, comma y, comma z, I have variables and I have real numbers combined to each other by adding comma subtract multiplying or dividing or power or root. So all of them make the algebraic expression. Okay, I'm going to give example. What does that mean? Exactly what I said here. So if I have, for example, variables like x, y, z, and real numbers combined to each other by sum, subtract, multiplying, or dividing, or power, for example, or roots, all of them make an algebraic expression. Example for algebraic expression, something like this: 2x square plus 3x minus 4. So as we said here, as we see here, so we see like variables x, and we see also real numbers 2, 3, 4. We see also the operation minus, plus. Also we see some power like 2, the power 2 here. Here the power is 1. So all of them we combine together, and these things they give me algebraic expression. Another example for algebraic expression, the square root of x plus 10. This is algebraic expression because we have the roots of the variable x plus we're using the operation plus the number 10. Another one is y minus 2z over y squared plus 4. So this is another example for algebraic expression. So here we use the variable y. Also, in the same times, we use the variable z. Use the numbers 2, I mean minus 2 and 4 and 1 here. And we combine together by minus, positive, and also dividing here. So this is also algebraic expression. Now, also we have another things we have to know. It's called the monomial. Monomial. This is the web assign questions about monomial. They focus in monomial and and also binomial and trinomial. So I'm going to define the monomial, and also I'm going to give example. So the monomial here, the monomial is an expression of the form a times x to the power k. So here, so the monomial is an expression of the form a times x such that x to the power k. This a here is a real number. This a here is a real number.
Isn't mono 1?
What is that?
Doesn't mono means 1?
Yes, this is like means one, or
So-
like I can use one term only. One
Yeah.
term, like anything of this term, a times x times to the power k is called monomial.
Right.
Yeah, what's your question?
No question.
No question. So anything of this form, like number 5 times x to the power 2, or anything here would be like called monomial. The k here must be non-negative number. Non-negative number means the 0 and all I mean non-negative number, I mean like 0, 1, 2, 3, 4, 5, 6 to infinity. Example for monomial, something like this: 2 times x to the power 4, 7 x to the power 15. What about 7, number 7 itself without any variable? It's a monomial.
It's a constant.
It's a constant, but it's a monomial.
No.
It's not a monomial, this one, 7.
Is
I
it?
think
Yes or not? Just raise your hand.
yes.
So,
I don't.
you know, yeah, it's yes or no.
I think it's
Can
no.
you, like, who said yes?
Chinaza.
7 is a
Chinaza.
monomial. No,
I said
no.
yes.
Eric, he said no. Rain said no. Who else said no? It's not a monomial.
I also said no.
No, okay. You, Shop, you said no. Who said yes?
Chinaza.
Janaza. Who else said the number 7 is a monomial? Also, Sahel Ahmed said no.
Oh, actually, any number by itself is a monomial. Never
Yeah.
mind.
So Jonah said yes. The answer is yes. Why? Because the 7, I can write it as of the form a times x to the power k. The 7 here, this is equal 7 times x to the power 0. Why x to the power 0? They give me 1. So if I can write this one of this form, a x to the power k, such that k here is 0 and a here is 7. So 7 is a monomial. This is correct. Yeah, the 7 is a monomial. Okay. Now for the second definition is the binomial. So binomial is sum of two monomial.
Just say, oh, so, oops, sorry.
Monomial. The sum of two. Yes, go ahead. Yes, sure. So the sum of two monomial called binomial. For example, example for this, 2x squared, 2x to the power 4 plus 7. This is sum of two monomial, so it's binomial. Another one is 5x to the power 16 plus x to the power 2. This is binomial. Another example is 17x plus 5. This is binomial. So the sum of two monomial, because I have two monomial here. This is the first one, this is the second one, this is the first one, this is the second one, and between each of them are the sum. So this is binomial. Same things here, first term, second term, and between them is sum. So binomial. Same things for the first example. Now the trinomial, the same idea, is the sum of three binomial. Well, three monomial. So here I can say the trinomial is a sum of three. Sum of three monomial called trinomial. Sum of two monomial called binomial. And the monomial is of the form ax to the power k. Trinomial, for example, here. So example, sum of three binomial like 2x to the power 4 plus 5x plus 7. So this is trinomial. Another example, 550, for example, x plus 7 x squared plus 2. This is another trinomial. And the same things, any three, the sum of three monomial called trinomial. Now, after we learn about monomial, binomial, trinomial, I'm going to talk about polynomial. So the polynomial, definition of polynomial. Polynomial is sum of monomial. Like the sum of monomial called polynomial. I mean, sum of one monomial called polynomial. So I can say here the binomial is polynomial. The trinomial is also polynomial. So anything of the sum of monomial called polynomial. So for example,
Poly means
7.
multi, right?
Poly means multi, yes. So for example, the 7 is polynomial. 2x plus 1 is polynomial. 3x squared plus 17x plus 4 also called polynomial. So the sum of any monomial called polynomial. Okay. So I'm going to give you the official definition of polynomial. So the polynomial. So the definition of polynomial is here. The definition, the official one, poly polynomial is of the form a and xn plus an minus 1 xn minus 1 plus dot 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 plus ax plus a0. This is the formal definition of polynomial. So in the web sign, also we have to know the degree is the highest power of the polynomial. Also, the degree is the highest power of polynomial. So the website has this question. This one. Hold on 1 second. This one here. 1, 2, 3. 2, 3. Here, polynomial. The type of this polynomial, the terms, and also the degree. So here I have the polynomial. Here I have the type. Here I have the terms, and here I have the degree. So the first one is this form, 2x squared minus 3x plus 4. Second example is ax squared. Third one is number 6. Now, what's the type of this polynomial? Any answer for the first one?
This is a polynomial or a trinomial.
I think it's a quadratic way.
We have 3 terms. We have here 3 terms. 1, 2, 3. So if I have sum of 3 monomial, it's called what?
Trinomial.
Trinomial. So this is trinomial. The second one. What is the type of the second one? We have only one term. It's called monomial, exactly, monomial. The third one, number 6,
Is also monomial.
is also monomial, yes. Now, what's the terms here for the first one? So the terms will be like this one, 2x squared, comma, minus 3x, comma, and 4. For the second one, we have only one term because it's monomial. So it's ax squared. For the third one is 6 only. Now, what's the degree here? What's the highest power of this polynomial?
It's a second degree.
It's second degree, exactly. What's the highest power here?
2.
It's also
2.
second degree.
What's the highest degree here? What's the highest power? It's what?
0 or 1?
It's 0. It's 0. Why? Because as I said here, number 7, for example, equals 7 times x to the power 0. So the highest power here is 0. It's not 1. So the degree here is 0. Make sense? Any question for this one? Okay. So now we're going to learn how to add and subtract polynomial. How we can adding and subtracting polynomial. So adding and subtract polynomial. So the first example, like this, about adding. So I'm going to give example for adding. If I have two polynomials of this form, x to the power 3 minus 6x to the power 2 plus 2x plus 4. This is the first one inside parentheses. The second one is x cubed plus 5x squared minus 7x. So first things, for adding polynomial, we have to remove the parentheses. So to remove the parentheses, I get now x to the power 3 minus 6x squared plus 2x plus 4. And here we have plus x to the power 3 plus 5x squared minus 7x. This is the first step. Now, the second step, we have to combine the variable
terms.
have the same, exactly, like terms. We have to combine the variable have the same power. It's called like terms. Like here we have x to the power 3. And also here we have also another x to the power 3. We have also here x 6 minus 6x squared. And here we have plus 5x squared. Also we have 2x. And here we have minus 7x. And the last one is 4. The 4, it's alone, does not have any other numbers.
Itself, it's a constant.
Itself, exactly, constant. So now I get here x to the power 3 plus x to the power 3 minus 6x squared plus 5 x squared plus 2x minus 7x. Okay, and the last number here is 4. Last things here is the number 4 plus 4. So now I can simplify it more. So if I have the same variable raising to the same power, so just I adding the coefficient of this variable. Here in the front of this variable is number 1, and here also I have number 1. So 1 plus 1, they give me 2x to the power 3. Same things here, I just adding and subtracting the coefficient. So I get here minus 6 plus 5, they give me minus 1 x to the power 2. Now here plus 2 minus 7, they give me minus 5 because I just adding the coefficient of the variable have the same power. So I get here minus 5x. And the last thing is here, the number 4 is plus 4. And that's it. This is the final answer. The final answer is 2x cubed minus x squared minus 5x plus 4. Any question? Clear how we can adding a polynomial? Now we're going to do it for subtracting. Same idea, but instead of adding, we're going to subtract. So here example, another example for subtracting. So the example is x cube, same example, not same polynomial, x cube minus 6x squared plus 2x plus 4 minus x cube plus 5x squared minus 7x. So the idea, first things you have to know, the idea is distributing the minus inside the parentheses of the polynomial. This is the first step. And in this step also we have to remove the parentheses. So I get right now here x to the power 3 minus x6x squared plus 2x plus 4. And after I distributing the minus inside the parentheses, I'm gonna get minus x cubed minus 5x squared minus times minus, they give me positive 7x. Now we're doing the like term, like I combining the variable have the same power. So x to the power 3 combining with this one minus x to the power 3 minus 6x squared, this one with the minus 5x squared, and the 2x with the 7x, and I left the number alone, number 4. So I'm gonna get now x cubed minus x cubed minus 6x minus 6x squared minus 5x squared plus 2x plus 7x, and the last things here, the last term is plus 4. So I should to know here x cubed minus x cubed, they canceling each other. So here I'm gonna get 0 minus 6x squared minus 5x squared, I get minus 11x squared. Like I said before, I just adding the coefficient of the variables. For the second one here, 2x plus 7x, they give me plus 9x, and the last term is the number 4. So I left it lefting alone like this. Okay, any question for how we can subtracting? Yes, go ahead. Any question? Is it clear how we can also subtracting to polynomial?
I think it's always too good to put it in the standard form, right? Go by the go by the degrees. 2, 1, 0.
Yes.
Yeah.
So you have to put it in the standard form. 2, 1, 0. Yes. Now let's go to the multiplying algebra expression. After we're talking about adding and subtracting, let's talk about multiplying algebraic expression. Any question before we're moving to the multiplying? No questions? Is easy? Okay, so here multiplying. Algebraic expression. So here the idea is using the distributing properties. This is the most important idea we're going to use in the multiplying algebraic expression. Like we talk about this idea, the distributing property in the first lecture in this class. For example, 2x plus 1 times 3x minus 5. So for doing this one, we have to multiply the 2 for the 2 parentheses. Then we're multiplying the 1. No, the 2, multiplying the 2 with the both term in the second polynomial, and the same things for the 1, multiplying the 1 with the first term in the second polynomial and with the second term of the second polynomial. So here I'm gonna get 2x times 3x plus 2x times minus 5 plus number 1 times 3x plus 1 times minus 5. And this is equal, when we multiply the 2x with 3x, we multiply the numbers together and the variables together. So 2 times 3, they give me 6. And x times x, they give me x squared. Have the same base, different exponent, or the same exponent. The exponent here is 1, and the exponent here is also 1. So I have the same base x. So 1 plus 1, they give me 2. Plus 2x times minus 5, just we're multiplying the numbers to each other. So minus 5 times 2, they give me minus 10. And I keep the same variable x. Plus 1 times 3x is 3x. Anything times 1 is the same. Same things for the other one. 1 times minus 5 is minus 5. Now let's simplifying the answer. So I get here 6x squared minus 10 plus 3, they give me minus 7x minus 5. Clear? Okay, I'm going to give you another example. I need someone help me for doing the second example. This example is 2x plus 3 times x squared minus 5x plus 4. So what I should to do here?
Can I do?
Yes.
So it will be 2x times x squared.
2x times what?
Um,
X squared.
X squared. Yeah.
Okay.
Plus 2x times minus 5.
Minus 5x.
Yeah, minus 5.
Okay.
And plus 2x times 4.
Times 4, yes. Plus what?
Plus 3 times x squared
Square, yes. Okay,
plus 3 times minus 5x
yes. Okay,
plus 3 times 4.
exactly. Thank you.
Oh,
3 times 4. Yes. So actually, she did multiplying the 2, distributing the 2x with the second parentheses like this. And the same things for number 3, multiplying the 3 with the all terms in the second parentheses. So now let's simplifying the answer. So I get here 2x times x squared. I get 2x because the variable have the same, I mean the exponent, because I have the same base is x, different exponent. So I just adding the exponent. So I get 2 plus 1, they give me 3, plus 2 times minus 5 is minus 10, and x times x, they give me x squared, plus 2x times 4, they give me 8x, plus 3 times x squared, they give me 3x squared, 3 times minus 5, they give me minus 15x, and the last things here, plus 12. Okay, now we can simplify it more. So I get now plus 2x cubed minus 10x squared plus, so we're adding this together here, like terms, this with this. And that's correct,
That's
right?
minus. Yeah.
Okay.
So that's and then
and we're adding this one with this one, and the 12 we left it alone. So I get now yes, go ahead.
7x squared minus 7x squared. I mean
minus, yes, minus 7x squared, because minus 10 plus 3 they give me minus 7 x
And
squared, yes.
minus 7x.
Plus 8 minus 15, they give me minus 7x.
Plus 12.
And plus 12. This is the final answer. Any question for this one? How we do multiplying? Any question? Is it clear for this one? Special product for multiplying?
No.
Okay. If no questions, the last things here before we leaving, it's talking about the special product formulas. For example, this formula, if I have, for example, A and B, here special product. Okay, so if I have, for example, A and B are real number, A comma B are real numbers, or algebraic expression, or algebraic expression. So I have to know A square minus b squared. This is equal, open two parentheses, and this first one is a minus b, and the second one I have to know a plus b. So this is for the, here we have special product formulas. The second formula, this is the first one. Second formula, if I have a plus b, everything squared, I have to distribute the square inside the parentheses, like a square, this is equal a square, plus 2 times the first term and second term, plus the second term squared. Is not equal a square plus b square. If you write it in exam, this is equal a square plus b square. This is wrong. You should to write also that 2 times ab, 2 times the first term times the second term. Third property is the minus. If I have a minus b, everything squared, the same idea exactly like before. We're distributing the 2 inside the parentheses. So I'm going to get the first one squared, but here instead of plus, I have to write it minus 2 times the first one times the second one times the first term times the second term plus the second one square, b squared.
If you can't remember this, you can just expand it out and see.
Yes, exactly.
Like you know how you square
Yeah,
a and b, just do that.
You multiply like a plus b times a plus b. You will get the same answer like this. So let me give you a easy example. What is the answer for 3x plus 5, everything squared? Who do this one?
I'll do it.
Yes, go ahead.
So since this is a binomial square, so 3x plus 5 times 3x plus 5 in parentheses.
This is correct. But what about using
Oh,
this?
which one you use? Number
yeah,
2.
which one? Number
Number
2.
2.
Okay, how we can apply number 2? Can you apply it?
So instead of a, you put 3x.
3x. Everything
Instead of
what?
squared.
Okay, plus.
Plus instead of b, you put 5 squared.
Exactly. So 2 times the first term, 3x, times the second term, 5. And instead of b, I have to put 5. So I get 5, everything squared.
Yes.
Now what I get? 3x, everything squared. I distribute the square inside the parentheses. What's the answer?
So
3 squared is 9. X
9x.
squared.
Yes. Plus
Plus
6x plus that's 30x.
2 times 3 is 6. 6 times 5 is 30. 30x plus
25.
5 squared is
25.
Okay. Yes, this is correct. So we're applying the second property for solving something like this. So I'm also another example, but I'm going to lift it for you, and we're going to do it together next time. So the example is again simplifying the fifth root of x times 2x minus 7 square root of x. So again, I'm going to give you just a small hint. You multiplying everything outside the parentheses to inside the parentheses, distributing. Then we're going to simplify it until you get answer like the previous example like this. Okay. Anyone has a question? Here I get a question from which one?
Yeah,
Which
to the
one? Okay.
problem. Yes.
Yeah. Okay. I get another question. When is the exam? The exam will be in the end of September.
Professor,
Maybe
so
after
what
like
topics are going to be there? Like mostly the prerequisites that
everything.
we did.
Yeah, will be like everything we finish up to last day of the exam, from the beginning of the semester until the last lecture we finish before
Okay,
the exam.
got it. Thank you.
Professor, we just
Okay, I'm going to stop up to here today. Any question for the class or anything?
Professor, so just in general, we just need to bring a like what general ID for when we come in.
Yes.
Okay, thank you, because
Any
I
general
don't have my
ID.
CCNY ID yet.
Yeah, any ID. Okay.
Professor,
Yes.
is it gonna be on the computer, like in there,
No,
or it's
it will
physical
be in
book
paper. It will be in paper.
paper? Perfect.
Yes. Do you have any other questions? Okay, we're going to stop up to here today. Please have a good night. Have a good day, everyone. Enjoy your day.
Also, is there no class Thursday?